Today we're going to begin Chapter 12 on rational numbers. We will be defining what a rational number is and then computing all operations with rational numbers. So today's lesson is on page 518, lesson 12.1. Our purpose today is to identify rational numbers and to be able to organize them on a number line. So first thing we're going to do is talk about what the word rational means. And as you've probably noticed, it has the word ratio in it. The word rational comes from the word ratio. Recall that you can write a ratio using fraction notation. So remember, a ratio is simply a comparison of two numbers, and one way to write it is as a fraction. So if you sleep for 8 hours a day, and then the ratio of your sleeping time would be 8 to 24 hours. A rational number is a number that can be written as the ratio of two integers. So anytime you could actually write a number as a ratio, that would be considered a rational number. So a whole number could be written over 1, whether it's positive or negative. And then decimals can also be written as fractions as well. So first thing we want to talk about is that a rational number is a number that can be written as a over b, where a and b are integers and b is not equal to 0. So basically what this means is it can be expressed as a quotient of two integers or written as a fraction. So in our center lighter colored circle here, we have whole numbers. All whole numbers can be written as rational numbers. All that we need to do is put a 1 underneath it, and we've proven that whole numbers are rational numbers. Then remember that integers, so everything in this second circle right here, all integers are simply positive and negative whole numbers. Then rational numbers are written in the outer square. So these are numbers that could be fractions, they could be decimals, but either way, we could somehow convert them to the example of a over b. Let's take a look at the fraction 3.5 written here in the corner. If I took 3.5 and turned it into an improper fraction, I would have 7/2. And 7/2 is proving that I can write 3.5 as a over b. Because you can divide any integer by any non-zero integer, you can use long division to write fractions and mixed numbers as decimals. Decimals are also rational numbers and will either terminate or repeat. So as you already know, if a fraction terminates, it just means that it does come to an end. But if it is repetant, it will be repeating, and as you already know, then you just put a line over the top of the decimal portion of the number, and it shows that it's repetant. So for example, the decimal -1.33333, it goes on forever, so we just write it as -1 and 3/10 repetant. Sometimes 2 or 3 numbers can repeat, as in this second example, and so then we just put the repetant over both numbers. So this is 15/100 repetant. Okay, so basically to turn a fraction into a decimal, you just take the numerator and divide it by the denominator. If you have a mixed number, though, you have to start by turning that number into an improper fraction, then divide. And so our first example, -2 1/4, becomes -2 25/100 repetant. My second fraction, I divide 5 by 11, and no matter how many times I keep adding another 0 and bringing it down, the 45 is never going to go away. So 5/11 is equal to -45/100 repetant. Writing a decimal as a fraction. Well, it's much easier actually to turn a decimal into a fraction than the other way around. If I read -26/100, it actually tells me what my denominator is. So My 26 is the numerator, and negative 26 hundredths goes out to the 100ths place, so that is the denominator. When I simplify it, I get negative 13/50ths as my final answer. This last example that we're going to look at actually takes our numbers, and we are going to be putting them in order from least to greatest on a number line. So the table shows the elevation of 4 sea creatures relative to sea level. Which of the sea creatures are deeper than the whale? So as you notice, the whale is already a decimal, but my other numbers are all fractions. It's much easier to compare multiple numbers if they're all in decimal form. So the first thing is to turn them all into decimals, and then we're going to graph each decimal on a number line. And our number line here, we're starting at 0 because all of my numbers are actually negative. And then as we move to the left on the number line, we are counting by negative 4/10. So here's my number line. And then we are just going to graph our numbers, all 4 of them. And what we're doing right now is comparing everything to the shark, or excuse me, to the whale, because it wants to know which ones are deeper than the whale. Well, here's my whale. So this shows that both the squid and the anglerfish are deeper than the whale.